So temperature can also have an effect on equilibrium. We've talked about exothermic and endothermic reactions. In an endothermic reaction, heat is going into, we have to put heat into, no, I'm sorry, heat exits. What am I talking about? Exothermic, heat exits. We can think of heat as a product because it's exiting the reaction. So if we were to draw that, we could get something like A plus B forming C plus heat. Heat is produced. It's a product. So we can think of the energy as a reactant or a product. In an exothermic reaction, heat's the product. Raising the temperature is like adding heat over here. If we add something to the right side, it'll shift to the left to use it up, to get rid of it. So the reaction shifts to the left. In an endothermic reaction, we have to put energy in. Heat is a reactant. So there we might have A plus B plus heat. Goes to C. So here, if we increase the temperature, if we add heat, adding something to the left makes it shift to the right. So we have the opposite effect of increasing the temperature on an exothermic and an endothermic reaction. Here's a specific example. So here's nitrogen and hydrogen reacting to form ammonia. This is an exothermic process. Heat is given off. If we increase the temperature, that's like adding heat. And so that will cause the reaction to shift to the left. Because if we add product, it will shift towards the reactants. Here, we're talking about removing heat. How would you remove heat? Well, you would cool it down. Stick it in the freezer. That will remove heat from it. If we remove a product, then the reaction shifts towards it to make more of it. Does that make sense? The opposite is true for the endothermic reaction. Here, N2O4, if we add heat to that, we get NO2. This is a brown gas. This is a colorless gas. So we'll see on the next slide that we can actually see the equilibrium shifting. Endothermic reaction, we're adding heat. It's taking in heat as the reaction occurs. So if we add heat, it's like adding a reactant. If we add more reactant, the reaction will shift to the right. If we remove heat, the reaction will shift to the left. And we see that in this picture. This is a sealed tube containing this reaction at equilibrium. So if we make this warm, if we heat it up, adding heat causes the reaction to go to which side? Adding heat makes it shift to the right, to the products. So we see more of the brown gas. And here at the warmer temperature, we can see the brown gas in there. You can take that same sealed glass tube and put it in a cold environment, and the color goes away. What's going on with that? It's just an equilibrium. When we remove heat, it causes the reaction to shift back towards the N2O4, which is colorless. And you can go back and forth and just shift the equilibrium by changing the temperature. And I'm pretty sure it's this sort of thing that's involved in the temperature-sensitive cups and spoons and T-shirts and various things like that. Mood rings. So this is a summary. In an exothermic reaction, heats a product, increasing the temperature, shifts it to the left, to the reactants. Decreasing the temperature, shifts it to the right. In an endothermic reaction, heat is a reactant. And changing the temperature causes the shifts to be in the opposite direction. You could memorize this. I don't recommend it because it's one of those either-or things. You kind of have a 50-50 chance. And there's very few clues to remembering. I think it's much better to understand Le Chatelier's principle of things shifting when you change them and trying to undo what you did, And then think, well, exothermic reaction, that means heat's coming out, heat's being produced, heat's a product. If I increase the heat, what happens? And just to think it out that way. And that's a lot more effective in the long run. Let's look at this reaction. 2SO2 plus O2 is in equilibrium with 2SO3. And we're told that this reaction is exothermic. Does that mean that heat is a reactant or a product? It means it's a product because heat is being produced. So just to help ourselves think about this, we'll do that. Plus heat. It's being given off. So what's the effect of increasing the temperature? How do you increase the temperature of something? You add heat, right? So we're adding heat. Is it going to shift to the right or to the left? To the left. It's going to shift away because it's saying, you added heat to my perfectly balanced mixture here. We need to shift things around so that we can get rid of that. So it will shift this way. So that will cause the reaction to shift to the left. What if we decrease the temperature? It'll go the other way. It'll shift to the right. Taking away heat, it will shift to replace the heat that was removed. Okay?